Welcome to chapter 2.4, more on inequalities. These are so much fun. So, what we're going to talk about today is the graphical approach and an algebraic approach, and then look at what happens when you have a polynomial and an inequality. So, a lot of fun stuff to come. Here we go. So, first thing, figure 1 right here shows the graph of the equation y equals x squared minus 4x plus 3. We're going to use the graph to solve each of the following inequalities. Part A, x squared minus 4x plus 3 is less than 0. Notice that's the exact equation of the graph. I want to see when it is less than 0. Okay, when is the this parabola less than 0? Well, it's less than 0 right at this point here, this curved area. That's below the x-axis. It's between the points 1 and 3. That is when that equation is less than 0. Hopefully then you can guess. The second part asks, when is that equation greater than or equal to 0? Well, that's at these parts. Notice I'm putting a closed circle because the inequality sign tells me to include. It's during those parts that will actually go on forever that the equation is greater or equal to 0. So that would look like, and I'm only talking about my x values here. So the x values would be negative infinity to the point 1 with a bracket, because you're including that point, and the section starting at 3 going on to infinity. So put the and, or write the word and, but those are the interval notations of what parts are greater than and equal to 0 or less than 0, looking at the graph. Pretty nice, right? Now let's actually take the same exact, different equation, sorry. We're going to take a different equation, and we're going to look at the algebraic approach, as well as we'll put a graph in it as well. So, first things first, when you solve, I always want to look for a GCF. Think of this as a normal quadratic, but now there's just an inequality symbol instead of an equal sign. So you're going to take out that GCF. It's greater than 0. Just bring it down for the ride. I'm going to factor this trinomial. Try to find two terms that add to negative 2, multiply to negative 3. You get negative 3 and a positive 1. Notice here, I now have a product that's greater than 0. So it's not necessarily the zero product property, but this will give us the x values that are what's called the key points. So you would see, I'll write this over here, the key points, or key numbers, whatever you want to call, is going to be, the first term is x equals 0, so 0. The next term, x minus 3 equals 0, forces x to be positive 3. The next term, x plus 1 equals 0. When you solve, you'll get those as my key points. Now the reason I don't call them the answers is because this is an inequality. No longer is it an equation. So these key values right here, negative 1, 0, 3, I plot on my number line, and I'm going to make little dashed lines through them. Because these are not the solutions, these are actually the key numbers, the key points that divide up my number line. What I do next is I need to find a test point in each section plug that point into the original inequality and see if it's true or false. I'll show you what I mean by that. Let's say we take a point in this left area, which will be -2. No rhyme or reason why I picked -2, but let's pick -2. I'm going to plug it in to the original equation. So notice I'm going to call this my test. My normal inequality up there, it would look like -2 cubed minus 2 times -2 squared minus 3 times -2. Is that greater than 0? Please put that question mark because you are questioning. If it's true, great. If it's not, then that's just not where the solution is. When you simplify this left side, I get -56. Is -56 greater than 0? No. So you can put a little sad face in this area. Some people like to put F for false, but you tested the first area to see if it's true or false. You can then test the point maybe like -1/2. Plug -1/2 to the original inequality, and you'll see that's actually a true statement. Next point, I'll try between 0 and 3. I'll just try the point 1. So I'm going to show this test. You should be showing all of the tests. So this would be 1 cubed minus 2 times 1 squared minus 3 times 1. Is it greater than 0? So I'm getting 1 minus 2 minus 3. Is that greater than 0? No. -4 is not greater than 0. So this gives me a false or a sad face. The last section, you can try any number, maybe 4. You will see it is a true solution. Which means these areas right here, goes on forever, is where the solution is. This is where the graph is greater than 0, so above that x-axis. Let's do a quick graph of this. I'll do a basic sketch over here. So here's my xy. My key points are -1, -1, 0, and 3. It's going to cross at those 3 points. We will talk about the shape soon, but if I were to graph it, it would look like so. Well, based on the graph, of course, from -1 to 0, it's above the x-axis, and from 3 on to infinity, it's above the x-axis. How you would write this as an, what form does it say? It doesn't tell us a form, but let's do interval notation. It would be from -1 to 0 and from 3 to infinity. Notice I am just doing parentheses because the symbol is just a greater than. So I want to know when it is above that x-axis. If the question was reversed, where is it less than 0? Well, you would pick the other 2 areas. So key points, a lot of checking, smiley faces, sad faces, and then you'll feel good to go. Here is written out in words kind of what we just did. So when you are solving a polynomial inequality, you want to rewrite it so that 0 is on the right side, just like we would if we were doing a quadratic like normal. Find the key numbers, list the intervals. For each interval, choose a convenient test point. Look above, we chose -2, -1/2, 1, and 4. Those were pretty nice. I mean, the -1/2 wasn't the best, but, you know, pick nice ones. And you then test those points. Let's try another one. First thing directions said is have it the 0 on the right side, which means let's move over everything from the right side. I'll get x to the 4th minus 14x to the 3rd plus 48x squared less than or equal to 0. First step, check. Now we're going to find the key numbers. How we find those key numbers is by factoring. Let's take out that GCF that we see. Leave the symbol like always. We can factor that trinomial in the middle to be x minus 6, x minus 8. Now we're pretty much doing a ZPP, a little zero product property, but keep in mind these are the key points, not the answers. So if you set x squared equal to 0, you get a key point of 0. X minus 6 equal to 0, you get a key value of positive 6, and the same thing for the last. You get positive 8. From there, I'm going to draw my number line. I'm going to put in those key values. These are not my solutions. In other words, they are the boundaries. And now I need to take some test points. Maybe like -1, 1, 7, and 9. Please take a moment, pause the video, and figure out which areas are true and which areas are false by testing the point in the original inequality. Hopefully you pause the video. In the end, you should see that this area was false. This one was also false. This part is true, and this one is false. If you didn't get one of those, please go back and check your work. But this would be the only section of the graph that is less than or equal to 0. Ooh, interesting. Less than or equal to 0. Let's keep an eye on that. So when I look at my answer, it would be between 6 and 8. Notice I include those values because of the equal sign. And also, whenever, I'll put a star, you see that equal to below, you should test the point 0. That's really important. If it's equal to 0 and the left side can equal 0, then 0 is a correct value. So let's try 0 really fast. And again, you only do it because that equal sign. So if I plugged into this equation, 0 to the 4th minus 14 times 0 to the 3rd plus 48, 0 squared, is that less than or equal to 0? Well, 0, 0, 0, yep. 0 is definitely less than or equal to 0. So you also need to include, this is a and symbol. This right here means the number 0. So the solution is the little range between 6 and 8, including those points, as well as this value of 0. Okay. You only do that again because it was a less than or equal to or greater than or equal to. You need to test for the point 0. Okay, so that's two really good examples with key points and testing what part is true and false. The next part would be what happens with an inequality where there are no key values. That means there's nowhere that it's going to cross that x-axis. Well, let's take a look. This problem says x squared minus 4x plus 5 is greater than 0. Same thing, when is it less than 0? Well, I'm trying to solve this. So I'm trying to factor, but I'm getting no real solutions. Okay, you could maybe get a square root of a negative. You might get some imaginaries, but there's no real answer. It says the discriminant is negative 4. Oh, look at that. It actually is a discriminant that's negative. So there's no key numbers. That means the polynomial never changes sign. Okay. So we test just one value. Let's look at this for a moment. Let's explain everything that was written there. Let's treat this as a normal problem. Let's say greater than 0. We're doing part A, let's say. I don't have a GCF. I try to factor, but I can't find any factors of 5 that add to negative 4. So my only other option is my friend, the quadratic formula. So you get 4 plus or minus underneath, that's 16 minus 20. Negative 4, there we go, that's why. This is imaginary. No real solution. That is why we can't find any key points. That's why right here it says no key points. So what we're going to do is test a simple point. For example, let's test 0. There's no range that I'm stuck with, so why don't I pick a nice number? Let's test x equals 0. If you plug it into the original equation, this part A right here, it is a true statement. What comes out, and that's right here, you get 0 squared minus 4 times 0 plus 5. Is it greater than 0? Well, yeah. 5 is greater than 0. Oops. Should be yes, true. So that means every single value is greater than 0. That whole graph will be greater than 0. It would look something like so. No key points because of this negative square root, and it is positive because part A is true. If you plug into part B, you'll see that it's false, a sad face, which means there'll be nothing below the x-axis. Now, this will not be a traditional partner challenge, sadly, I'm sorry. So what you're going to do is you attempt them. Maybe work together with people in your group, get a text thread going, maybe FaceTime, do a little Zoom to try to see if you guys can think of these 3 answers. If you come into class with them right, I will give you a little points or 2, and that will be your partner challenge. Good luck!